Hello there, it's Mr. Munoz. Just going to do a quick explanation of what's going on with these notes. You see the title here, Polygons, Quadrilaterals, and Perimeter. So we'll just start with, well, let's see what it says here. Understand how to calculate interior and exterior angles of polygons, and understand how perimeter can be used in real-life problems. So your two main objectives. Starting out here, just knowing names of polygons based on their sides, right? So depending on the number of sides, we have a name. 3 sides triangle, 4 sides quadrilateral, 5 sides is a pentagon, 6 sides is a hexagon, 7 sides is a heptagon, 8 sides is an octagon. You may see there's some words that aren't listed here. You may see a word nonagon. Nonagon is 9 sides. Decagon is 10 sides. There's also a word for an 11-sided shape. It's called a hendecagon. Not super relevant to remember, but it's out there. And then there's also a word for a 12-sided shape, dodecagon. After those, I think it's just like, again, dodecagon is 12, so 13 is just a 13gon, or 14 is a 14gon, 15 is a 15gon, and so on. A 25-sided shape, we'll just call it 25gon. So there's that. Here, the definition for regular actually becomes relevant. The word regular tells us a lot about a polygon because it tells us all the sides and angles have the same measure. There's also a formula here for getting the sum of all the interior angles of a polygon, and all you need to know is the number of sides, so that would be n here. Depending on how many sides the polygon has, you could plug that number in here. Like you could plug in, for an octagon, you could plug in an 8 right here. 8 minus 2 is 6, and then 6 times 180 would give me all the total of the measures of all the interior angles. You should have seen that in the Desmos we did. The exterior angles always sum up to 360, so that tells me that as we have more sides, the exterior angles get smaller and smaller because they always total up to 360. Right here you can see a quick sketch of, it looks like an octagon, and it shows an interior angle here, A, and then the exterior angle is only really shown by extending one of the sides out. And the first problem, the sum of the measures of the angles of an octagon. The sum of the measures is the interior angles, and just using this formula as mentioned a second ago, plug in an 8 into this formula for 8 sides. 8 minus 2 is 6. 6 times 180 is 1080. There's 1080 degrees. It's the sum of all 8 interior angles here, which they're not labeled, but there's A. Then there's the second one, 2, 3, 4, 5, 6, 7, and 8. There's 8 angles total, 1080 degrees for an octagon. Find the measure of one angle of a regular octagon. Well, one angle is going to be that sum divided by 8. Again, regular means all the angles have an equal measure. So if all the angles have an equal measure, we could just take the sum and divide by 8. So that's 135. The measure of one exterior angle, well, if you look back here, remember the exterior angle's total sum is 360. So if it's regular, that means, again, all the angles are going to have the same measure. So an octagon is going to have 360 divided by 8 to get the measure of one exterior angle. It's 45 degrees. But you can also see here that between an interior and an exterior angle, you end up with a straight line. So remember, a straight line is 180. So if you just took 180 and subtract 135, again, 180 and subtract an interior angle, you'll be left with an exterior angle. So here's 2 methods for getting the exterior angle. If you know an exterior angle, you could subtract from 180 to get an interior angle. That is another option. So again, but you can see here that the 2 angles together, A and B, they are one interior and one exterior angle, and together they make a straight line. So that's why you could take 180 minus, what we did was 180 minus A to get B, 180 minus 35. Again, the other option being 360 is the total for all the exterior angles, so 360 divided by 8 gives us the same answer. This is a little bit of the same here. The sum of the measures of a 12-sided polygon, it's just S equals 180 times n minus 2, n being the number of sides. So if it has 12 sides, 12 minus 2 times 180, which 12 minus 2 is 10, and 10 times 180 is 1800 degrees sum for all 12 interior angles of a 12-sided polygon. That'd be a dodecagon if you want to name it. Find the measure of an angle of a regular 12-sided polygon. So again, it's just pointing out here, this should have said interior angle. And so if it doesn't say interior, it will assume it's inside the shape. And so one interior angle could simply be 1800 divided by 12. Again, the sum of all the interior angles divided by 12. Again, that works because regular means that they're all equal. So 1800 divided by 12 gives me 150 degrees per interior angle. And we can go on here. There are some properties of these different shapes that you're going to have to know. So the front side was, again, it was polygons, and try to know them by name. Try to know how many sides they have based on the name. And then again, make sure you know how to get the sum of the interior angles, or one interior angle, or one exterior angle, depending on the problem. And again, so flipping to this side, we may need to know a few things about a parallelogram, a rhombus, a rectangle, a square, or a trapezoid. You guys already know a bit about these shapes, but you may have to know a little more. Let's see what we got. Perimeter. So this side talks about perimeter. It's not talking about angle measures anymore. Perimeter is the sum of all the side lengths of a shape. And so add up all the side lengths to get the perimeter. Then let's see what example 1 says. A rectangular field has a length of 42 yards and a width of 28 yards. If fencing costs $5.25 per foot, find the cost to enclose the field with fencing. So right off the bat, this problem is using yards and feet. So right off the bat, I could mess this up if I don't notice that. So what I did was I found the perimeter. It's rectangular, so it has two sides of the rectangle, right? If you look back at a rectangle, two sides of this rectangle we're talking about are 42 yards, and then the other two sides of this rectangle we're talking about are 28 yards. So right here, my perimeter is two sides that are 42 yards plus the two sides that are 28 yards for a grand total of 140 yards. But then the price is per foot, so I gotta change this into feet, and I need to know that there's 3 feet in a yard. Again, a bunch of info that hopefully you're familiar with. It's fairly common, but try to be familiar with it. So anyhow, 140 yards times 3 is going to give me my feet, which is 420 feet, and then I can figure out how much the total is. So at 420 feet times $5.25, I can get the total cost of this fencing, and you can see it's $2,205. So this problem's pretty doable, pretty straightforward, but just be careful with the feet and yards part. That part makes it a little bit easy to make a mistake. Again, right here, right? Don't forget to change yards to feet. So let's see here. A rectangular field, same type of problem, has a length of 50 yards and a width of 30 yards. If fencing costs $6.50 per foot, find the cost to enclose the rectangle with fencing. So once again, and here, instead of doing 2 times 50, I just added 50 twice. And instead of doing 2 times 30, I just added 30 twice. So you get the perimeter by adding up all the sides. And if any of the sides are the same length, you could use this technique of multiplying, since they're the exact same length, 2 of them. Either way, I got 160 yards. And again, the price they gave me was per foot, so I have to change yards to feet by multiplying by 3. Got 480 feet, and then 480 feet times 650 is $3,120. So these problems are pretty basic, but definitely be careful with the feet and yards stuff. So that's really it. And then, right, so just to sum up, there's this formula here for getting the sum of the interior angles. Remember, if you have a regular polygon, all the angles are equal, so you could just divide by the number of sides to get one interior angle. If you have an interior angle, you could subtract from 180 to get an exterior angle, and vice versa. The sum of the exterior angles is always 360, though, so that's different. I don't need this formula for the sum of the exterior angles. And then the perimeter stuff, right? The perimeter problems are not just asking us for perimeter, they're asking us to find a cost of something also, so be careful with that. The feet and yards aspect of it, again, makes it tricky. So hopefully this is not too difficult. Give it a shot. Thanks for having a look.